welcome to episode number 23, I believe, for the ZoomTown experiment series. For today's episode, we're going to cover a lot about the MQTT communications. This will not be a full nor complete tutorial on how to utilize and implement MQTT, but it's more associated with how it applies to our purposes in the ZoomTown experiment. Let's start by taking a look at the framework, so to speak, of how this plays in our system here. We're looking at just a simple diagram here. Over here on the left is what I call the Zoomies. This is what's happening there. There's going to be, currently it's planned for 16 total Zoomies, each running on a PICO. When it's communicating via MQTT, that is going through the Wi-Fi off to a server or a broker, as it's called in MQTT terms. Now, the broker that I'm using is Mosquito. It's running on a Raspberry Pi 3. Oftentimes, I've been able to get the broker to run, because it just runs in the background. You don't interact with it at all. You install it, get it running, and anytime it's on, it's doing its thing. But I've normally been able to get the broker to run in another Raspberry Pi, like I'm showing over here in the lower right corner. This is my scheduler. This will be the computer that controls all of the PICOWs and all of our Zoomies. So this normally would be installed in here, but for some reason something was getting goofy. And so I just decided I had a PICO or a Raspberry Pi 3, threw it in there, and now it sits over on the other desktop. And I'll be showing you that layout here shortly. But each of the Zoomies has to communicate with the scheduler, and the scheduler is the controller of the whole ZoomTown experiment. So these are passing pieces of information back and forth, often very frequently, and I'll explain that more so in code. But to handle all that communication and to direct it through the Wi-Fi network, that's the purpose of the broker, or in our case, the Mosquito MQTT broker. So this guy just does his job. We don't really interact with it at all. From the Zoomie's perspective, we need to publish our telemetry data very frequently, and that will consist of velocity and positional data. We also need to subscribe to topics coming from the scheduler, and those topics would include directions, cycle start, feed override, and e-stop. Over here on the scheduler, we're going to be publishing the topics directions, cycle start, feed override, and e-stop. And this will subscribe to each of the Zoomie's telemetry data. Directions up here in the publish will be sent to each specific individual PICOW. So as you see here, each PICOW has, or each Zoomie has to have its own ID. We'll explain that once we get a little further down in development in how we're going to address that issue. So for right now, understand this. There's a broker running on an Raspberry Pi 3. It doesn't require any interaction from us other than to just simply have that little computer turned on. There will be 16 Zoomies, each with a unique ID, and that'll be publishing, or each of those will publish telemetry data and subscribe to direction, cycle start, feed hold, and e-stop. That information passes through the broker over to the scheduler running on a Raspberry Pi 4, which publishes these topics and subscribes to these. So the important thing to remember with MQTT, you're going to subscribe. Any device is going to subscribe to topics it needs to have information about. And it can publish any information as well. And whichever other devices on the network subscribe to it, that data will be routed to them. As we did last week, we'll take a look at the code. Now, most of this has already been covered last week, and we really won't be running anything today because this will be a two-part video. But we're going to start in this area of the code called Configure Networking and MQTT Comms. We need to import network, which is a MicroPython library to allow us to access and communicate over Wi-Fi. We're also going to import MQTT client from the library called Simple. That's a library that you'll have to download, or that I downloaded off the internet. I'm going to import this file, import zprofile. That is a Zoomie specific. That file there is Zoomie specific, which will have credentials for logging into the Wi-Fi and MQTT, and it has data. Now, because that is so important, I'm going to jump over and show you that right away. Inside that file is the credentials for logging into Wi-Fi and into the MQTT server. As you can see, I've blocked out some things, so this isn't the actual file, but what needs to be in here is the login username, the Wi-Fi password of the Wi-Fi access, or my access point. Then, once that's all established in the other code and we get connected, then we can work on establishing contact with the broker, and we have to give that a server name, which would be an IP address as shown here, and that's the broker's IP address, an MQTT host name, and that's the name of the broker, and finally we have to pass it its password. And of course, you'd actually have real passwords there, not a number of X's. The Zoomie IDs will range through the numbers 0 through 9, but not all of them, because 6 upside down looks like a 9 and can look like a B and all that. So I'm also using some of the other symbols. So for this one, the Zoomie ID for this particular Zoomie would be $. The backslash is just the continuation code used further into the system. It's not part of the ID character. This list here of subtopics contains all the subtopics this Zoomie ID will be subscribing to: velocity override, cycle start, and e-stop. And eventually that'll include a bit more about directions and all that sort of thing. Now I'll have a zprofile.py, not the vid one, because that's what I'm using here in video, but each Zoomie will have that file customized for it. And then that way I don't have to maintain 16 different source codes of programs, one for each individual Raspberry Pi PICO W, or one for each Zoomie. So that's what's going on with this guy. So anytime you see that Z profile, it's actually loading in or accessing zprofile.py. So from there, we're going to get the internet name and the internet's password, and that really refers to Wi-Fi in our case. We're going to create a Wi-Fi object, so to speak. We're going to set its activation to true, and we're going to connect to that wide area network, or WLAN, and we'll pass it in our ID, and we'll pass it in the password just as if we were logging in at the keyboard. And then we have to wait until I get Wi-Fi connection. So this will try, keep trying, it'll check to see if it's connected, true, or not connected, false. And if it's false, it'll say waiting for condition, sleep for a second, and then repeat. So at some point, if it doesn't connect, you'll have to abort out and then try again. It can be a little goofy sometimes when it's logging into the Wi-Fi, but once you understand its behavior, it settles down and you know how to deal with it. We're going to, once it's all connected, I just print out that we've been connected. Now we're going to start setting up our client ID for the MQTT. We're going to get that data from the Z profile file name. We will initialize our client using the data from there, using the client ID, server name, host name, and password. All that data, of course, coming from the profile. Now at that point, we're still not fully connected yet, but I dropped in this function in this location to help me with finding things as this program got bigger. Now you'll notice this code here is all fully on the left, so this is running at power up. This would be a function, it's not called yet, so it would skip over this on power up, and then we pick up here where we're going to set the callback function for handling all incoming messages, and that is this function, the receiver callback. We'll go back through that here in a minute. I'm going to say at this point we've made connection to MQTT, or we're going to make connection. This is the attempt to connect, and if that all passes fine and dandy, I'll print out that we connected to the client. And then in this area here, we're going to go through each element in the Z profile subtopics, which is right here. This is the profile subtopics, and each one of these elements or items in the list. We'll iterate through those one by one and tell the MQTT client to subscribe to each one of those. And then we'll print that out as it's happening in real time. And again, this is startup code. At this point, we are all connected and we are subscribed to all the topics. Now, from here, the next aspect of all this is now we're going to get into the functions that will start running or allowing us to communicate through the MQTT broker and network. So we're going to go back up to that previous function and see how we're going to handle incoming data. Now, we'll repeat some of this discussion again next week in part 2 of this one. But let's just cover it now so you got a foundation of how this is going to work. In this function, we're going to be working with 3 global variables right away. SVCS, SVOR, and eStopS. The names aren't super logical, but my thinking was system variable cycle start. And that'll be a green switch on the scheduler enclosure for the Raspberry Pi 4. SVOR is system variable override. That'll be a message coming from there based on a rotary multi-position switch that can be set to a value of 1, 0.9, 0.8, 0.7, 0.6, or 0.5 as it's currently configured. And that'll be a control to override the velocity at which the Zoomie is moving. And that can be executed or changed at any time during the simulation as it's running. And then finally the eStop switch. There is one of those on the control panel or the Raspberry Pi 4 enclosure. And that will either be a start or a hold. I might change the meaning of that as the code develops further along, but for right now it's I'm just thinking of it in terms of start or hold. We are going to decode the comms that are coming in. We're going to get the topic and the message, and that has to be decoded using this format. And then from that, we're going to look to see which topic comes in. Now remember, this kind of happens, so to speak, automatically. So if the topic, and it's a longer string of text, and that's why I'm using a substring of it, and I'm looking for the word eStop. So if the topic is equal to eStop and the message is equal to stop, then I'm going to set a system variable, eStop, to 0, meaning set it to its current state of active. Then I'm going to print out on text, eStop is pressed down. Likewise, if the eStop is pulled out and reset, that would be the message that's coming in. It would be reset, eStop. I will set that system variable to the current state, 1, meaning it's up, and then print a message on that. We'll do the same thing for cycle start button, and we'll do the same thing for the override. And this is called VEL underscore override, and that's velocity override, shorthand. But I need that as a mathematical or a numerical piece of data as opposed to a text string. So I'm going to convert that into message value. So I want the value of that. And if that value, now I'm doing numerical comparisons as opposed to textual or string comparisons. So if it's less than 6, that means that the system variable override needs to be set to 0, because that is where I would actually put it into like a hold state. And then I'd print out the statement that we're at 50% or lower, meaning we need to stop moving all the zoomies. Likewise, if it's over that, anything greater than 0.6 or greater, then we're going to set the system variable override to that value and then print that out so we all know what's going on. And again, that will happen with the values of 1, 0.9, 0.8, 0.7, and 0.6. 0.5 and anything less would be stopped. So that'd be 100%, 90, 80, 70, 60% override is what that amounts to. So that covers that function. There's another function and another operation that's running constantly with the MQTT communications. And I am transmitting to the scheduler the direction, any marker that the Zoomie has encountered, the control marker, like a stop sign, a traffic control marker, the velocity, and the odometry, how far or what position it's at. So that information is passed into this function, and then I use the Python's function of join to pack all of that data into a very into a simple singular element that could be then passed into the scheduler, where it would be decoded over there. And this was used, this join function was researched to find something more efficient than the alternative, which is to send 1, 2, 3, 4, 5 variables via MQTT communications. That's a lot of data traffic for the network. Or to try and pack it in some simple decoded or a simple encoded string message. This turns out it is much, much faster, probably 10, 20, 30 times faster than doing it the other ways. And then we just simply say when we pack that data that the pad and packet function was created. So now let's go all the way down into our loop where the rest of this is going on. And we got to find it. Oop, not there. Okay. This will be in our main loop. And it will not run every 5 milliseconds. Instead, what I'm doing is running it every 30 milliseconds. I don't need the data passed around that frequently. If I need to, I can decrease this counter and send the packets more frequently. But right now I'm limiting it to every 6 times through the main loop, which is 5 milliseconds. So every 30 milliseconds, this packet of data is sent to the scheduler. And that's forward direction, the state of the first Hall effect sensor, our stop sign sensor, our run velocity, and the position we are currently at during this specific move. That gets sent there, gets packed up, and it's returned and put into the word or this variable message. Now you'll see the CP4, 5, and 6 These will stay in here. All they're doing is helping me to measure the cycle time for each of the tasks in this process. Early on in this project, I was talking to one of the viewers, and he was very adamant that MQTT was a waste of time and would take way too much time to even be effective on a microcontroller like the PICO-W and with MicroPython. And normally I often will take people's advice, but I'm also wise enough to know that I need to explore some of these things to see if their knowledge is current to the existing situation today. We all learn lessons in our lifetime and learn information. And unfortunately, in the world of MicroPython and the PICO-W and everything we're doing here, this is changing very rapidly. And if you've been updating the UF2 file on your PICOs, you'll kind of notice that there's some pretty substantial changes happening, and you kind of need to keep up with everything. MicroPython is changing as well. So what could have been true literally 3 months ago, today could be totally untrue. So I take other people's advice, but at the same time, I have to investigate further. So far, I've got to say the MQTT is showing wonderful signs of being the correct choice for this communications. But nonetheless, I'm going to monitor it very carefully. So that's what this line, and this line are all about. On this line here, we're going to publish this message and topic, and we're going to publish it from the ID of this particular Zoomie, and the topic is called Telem for telemetry, and then the message data that's packed into this variable. We will then check for messages, and that executes our handler, which is way up here, right here. This is our handler, so this will execute and take care of any incoming messages. And we'll get all the way back down to here. That was that step. And then we're going to, because we did the execution, we hit our limit at 6. We reset that counter back to 0. And then immediately we're going to increment the counter to 1 to be equal to 1. And this runs, of course, all the time from our main loop. Now we'll take a quick look over at the other station where the scheduler is and the broker, and that's right over here. Over here at the control center for the ZoomTown experiment, I've got our scheduler computer, Raspberry Pi 4 in a custom-made enclosure. It contains a cycle start switch, a push-button style emergency stop, and a rotary selector switch that allows me to control how fast the action happens in ZoomTown. I also have a Raspberry Pi 3 running the MQTT broker software. And this one you'll notice is headless, so I do everything on that, which is very little that I got to do with it, other than shut it down. And I use VNC Viewer, which is running on the scheduler, and that's how I'm connecting into the broker. So when I need to shut it down, I just come in here, click, shut down, and shut down, and now the broker is being shut down. So I have very minimal interaction with that device. Once that's out of the way, then I would shut down. Because we're all done for the day, I will shut down the scheduler. So at this point, we've got a good framework to work with the MQTT. Next week, we're going to dive into actually testing the code here on the scheduler, which will be a very simple test program, and then back over at the electronics bench where I do all the work with the Zoomie. So next week, we're going to start getting into some more interaction with different devices. I look forward to seeing you then, and thanks again so much for watching and following along with the ZoomTown experiment.